Welcome to the Micronaut podcast. I am your host, Sergio del Amo. I am here today with a special guest. I am here today with Sakis. You have also complicated names. Sakis Kaliakoudas, I guess.
Oh,
are you Greek?
Almost there. Kaliakoudas. Yeah, I'm Greek. Great to meet you.
Kaliakoudas. But you are actually based in the UK, right?
That's right. In the rainy London.
In the rainy London. We were just talking before the recording the podcast. So Sakis called my attention when he wrote a great blog post about using Micronaut Kotlin and AWS Lambda. We'll talk more about that later. But before going into that, where do you work, Sakis?
So the tool that we've built is called Caribou, which is a tiny startup that we started about a year and a half ago. And it's looking to help engineering teams track their technical debt better, and more specifically, track how they migrate away from their technical debt. So any sort of large-scale refactorings that they do, like let's say in Android engineering projects that we are focusing on, because this is our background, things like moving from Java to Kotlin, or changing the architecture of the project, or removing some libraries, things like that.
Yeah, we do actually for many clients, not especially the kind of Kotlin to Java or Java to Kotlin, but we have helped many clients migrate, for example, from all versions of Grace, from Grace 2 to Grace 4 and 5. So having such a tool, I think it will be, it's interesting, an interesting idea. How big is the startup? How many of you are involved in the company?
There's 3 currently in the team, 2 on the engineering side and 1 designer.
Nice. That's the pizza size team.
Exactly.
We will include a link in the show notes to the software as a service application in case anyone is interested or actually had the need for such a tool, which I am pretty sure that Sakis will be able to guide you through using the tool. Before going into talk about Kotlin, Micronaut, and Lambda, let's talk about the agenda first. For agenda, I'm giving a talk in the Manchester. Now that Sakis is based in the UK, I'm giving an online talk in the Manchester Java user group on the 17th. That's in lunchtime for you, Sakis. And it's a bit early for me to have lunch, but that's the time of the talk. I'm giving a talk also. We are actually doing, and this is quite related to our conversation today, we are doing an AWS Lambda plus Micronaut training, the 3 days, 3 hours a day. That's the 28th, 29th, and 30th of March. I will include a link as well in the show notes. And Micronaut co-founder, Graham Rocher, he's talking in a couple of conferences, J on the Beach here on Malaga in Spain, and also in JFocus, Sweden. I may be I will probably do a talk in Barcelona Java user group, but that's still not confirmed, so stay tuned. As always, we have a list of upcoming events on micronaut.io/resources/events. So keep an eye on that. Do you have anything coming on your way that you would like to promote in the agenda section?
Not quite, no.
That's fine. With that, let's move to Level Up, which is this section that we have about tips and tricks about using the framework. In the Level Up section, we typically give you like hints to classes that you may not be aware of. But today, Sakis was just talking to me just before we started recording, and he told me that he had helped the combination of Micronaut plus IntelliJ IDEA Ultimate combo. Great. And without further ado, I let you talk about what has been your experience and in which ways have IntelliJ helped you.
Absolutely. So I think that when we started with Micronaut, I wasn't aware of this integration. I think I wasn't working with the ultimate version of IntelliJ, but a few months later, I happened to use it, and I was surprised to see that the Micronaut plugin within IntelliJ gives you some checking of the repository interface that you write. So the functions that end up, behind the scenes being translated into SQL code. So this plugin checks your domain, like your domain definitions that map to SQL tables, and it provides you with suggestions about all the projections that you need to do, the filtering, and things like that. So if you have any sort of typo in your function declarations, it spots that and you can correct it easily, which is amazing.
Yeah, we use IntelliJ Ultimate as well here in the company in object computing, and I really like it a lot. I have not used much the repository help, but what I have seen and that I really like is the support for the configuration autocomplete, which is really nice because that's probably another tip for everyone. In all the Micronaut modules, we have this section. When you go to the reference documentation, we have a configuration reference tab on the top. That documentation is coming directly from the source code. So that configuration is the source of truth. I like to say that's like the Bible. What is there is the correct thing. And IntelliJ idea is really nice because it essentially autocompletes all of that configuration reference. So if you want to like configure microsecurity, which has a bunch of configuration options, that's really nice. Yeah, IntelliJ idea is my IDE of choice as well. So if anyone is looking for an IDE with great Micronaut support, that's one. I know many people also use VS Code and they're quite happy with it building Micronaut applications. I have not used it myself, probably because I have so much, so much experience with IntelliJ that it will be a hard transition to me to move away. But if you are either using IntelliJ or VS Code, you should be in good hands. So let's talk first about the architect. So you are using Micronaut to build Caribou, right?
That's right, yeah.
And what's the architecture of Caribou? So it's a software as a service application. I guess it has a web application front end.
Yeah, a React front end. And then in the backend, we just use AWS Lambda. There's nothing else.
So you are using essentially Micronaut to essentially power that JSON API.
Yeah, that is correct. Along with some other lambdas that we run as workflows, so like using AWS step functions or some tasks into queues, for example.
Nice. So that's a good. And you are. So let's go step by step. So for those new to Micronaut integration, for those new to Lambda, right? So Lambda is this serverless service from AWS, which allows you essentially to write what they call functions. And these functions, essentially, they have one important component, which is how are your functions triggered, right? The functions is code that it gets executed when a trigger happens. And based on what you told me, my gut feeling is that you have in front of some of your Lambdas, you have API gateway connected.
Yes, that's correct. So, maybe just to start from the beginning of the story, when we started with Caribou, we wanted to build a backend to serve a REST API for our frontend, and me and the other technical co-founder come from a background of mobile development, so not so much experience building a backend, and we were trying to, as any startup does, get something up and running quickly. So we wanted to assess whether it would make sense for us to go into the world of Docker containers and instrumentation of those and microservices or some other service that is online all the time. VS, the new kid in the block, which is AWS Lambda. So we tried to assess these two. We did some small scale experiments, and we realized that the overhead of learning everything that has to do with containers would be bigger compared to just going with AWS Lambda, because AWS manages with Lambdas, it manages a bigger part of the stack. So that is why we went with AWS Lambda. And then, as you said, the end goal, as I said, is a REST API. So we used the AWS API gateway to receive to manage the request, and that proxies the actual request into the Lambda functions that sit behind it. And Micronaut is the framework that powers, this integration. And of course, we use it for other things like the database that we've discussed earlier.
You said a couple of things that are interesting that we'd like to cover is, so you were mostly mobile phone developers, mobile phone application developments. I guess you were Kotlin developers?
Yes, that's right. We had transitioned from Java to Kotlin maybe 2 or 3 years ago.
Correct. So you were in the horrible Android Java world with almost Java 6 there, it seems like. And do you find Kotlin in the mobile, which is a revolution if you compare with the version of Java that you typically use in Android? And then you never look back.
Absolutely. This was one of the main requirements. We were like, we love Kotlin so much that we want to build our backend with Kotlin. Let's find a way to do it.
You can build Micronaut applications with either Java, Kotlin, and Groovy, and we see many, many Kotlin users. And we don't know the exact numbers because if you generate a Micronaut application with the CLI, we have no idea. So it's difficult to tell. But based on the issues and some metrics that we have from Micronaut launch, I think it's fair to say that between 30 to 20% of our users are Kotlin users. And also based on the number of issues and comments in GitHub and things like that, you more or less measure the temperature of how many people are using Kotlin and Micronaut, and they are actually quite vocal. So going back to the API Gateway story, for those who are new to AWS Lambda and API Gateway is this AWS service which allows you to configure some routes, like, I don't know, like /books post request, and you can say delegate all these routes to this Lambda or to multiple Lambdas or to different Lambda. This generates one trigger to Lambda, which is this API Gateway event. And when you typically get an API Gateway event, you are supposed to answer back with an API Gateway response, right? And for this scenario where you are receiving an HTTP trigger, we have two ways of building Micronaut applications. One is what we call using the default application type. And another one is using what we call the serverless function. And based on your product, my intuition tells me that you are writing your application with controllers.
So anything that talks to the API gateway uses the controllers, as you said. But we have a few workflows where we're using the other way of defining Micronaut lambdas.
Let's discuss the other one as well. For those, the nice thing when you are responding to HTTP triggers event for listeners, the nice thing and what Sakis is describing is that they can write their applications that they will use and deploy the application to using the native runtime. So they will have controllers, they will have add body annotation, add post, add get, things like that. They will deploy their code to the Lambda runtime, and it will be transparent for them that it's running on Lambda. Mostly, I hope. How have been your experience been for that? And I am especially interested in testing.
Sure. Yeah. So mind you, we started about a year and a half ago. I think that the framework these days is much more robust. When we started, we did find some issues, like some small issues, but it wasn't something that we didn't manage to figure out in the end. And in many cases, with your help, because there is a great Gitter community where we asked a bunch of questions, and the fine people in your team were, replying and helping us out. I think fast forward to today, I don't think that there is a single issue that we would have encountered.
For this main Lambda, this main application, you are saying that you are using microdata. Are you using a relational database for a program? Are you using DynamoDB? What are you using for persistence?
MySQL database is what we're using.
And you are using MySQL with microdata JDBC or?
Yes.
Nice. That's a combo that I often don't see. Many people that go the Lambda route, they go also the DynamoDB route. So that's nice to hear that and you are hosting the database in RDS?
Yes, that's right. Yeah. And this mostly stems from the fact that we had a lot of experience working with a SQL database, but not so much with DynamoDB. So we went down the route of, speeding things up.
Yeah, I can imagine. Microdata is also really... We have a much better developer experience for relational database than from DynamoDB. That's an area that I would like to improve, but as of right now, is we have a better experience for for microdata. So that takes care of the REST API. And then another thing that you were saying is you are using triggers. So when you have like for those of you who want to understand what happens when you are using controllers in Lambda is we actually have a handler that we provide you. So you don't have to write the handler that typically you will write if you like write a Lambda from scratch. And what the handler does, it receives the AWS API Gateway event. It essentially transforms it into an HTTP request that Micronaut is able to understand. And it routes that request to the appropriate route, which normally is a controller method. And then when the controller responds back, it takes that response and it does the other way around, which is it transforms that response to the API Gateway event in the handler and responds that back. When you have other triggers, and based on what you told me, I guess you have some triggers to do like schedule jobs.
Yes, that's right. So an example of this is when so what Caribou does, just to start from there, is that you define a migration and you say, okay, I'm going to do this migration and I want you to start monitoring a branch, let's say the develop branch. So every time a PR is created and merged into that branch, Caribou in the background will check out that branch, perform some analysis based on the migration rules that you have defined, and then store the results to show them. So that part happens as part of an AWS step function, which we can think as a way to create composable workflows. And for our case, each step of this workflow is defined using a Lambda function that we glue together.
That's nice. So for those Lambda functions in the step functions, are you using the Java runtime? Because those are not so time sensitive to call the startups. So one of the issues that you will face if you are like working with any serverless technology is call the startups, especially in the JVM. This is an area where we have improved. So in Lambda, for those new to Lambda, you typically select a runtime where you want your function to be deployed. So a runtime typically will be like a programming language. So you will be like, I am writing my function with JavaScript, I am writing my function with Python, or I am writing my function with Java. And for Java, there is like the JDK, I think they support right now 8 and 11. And you essentially, if you are using the Java runtime, for us, is typically you will upload a fat jar. And what AWS does is when is serverless, but there are servers. This is the joke always. And they are only gonna build you for invocation, which is great for startups and for everyone, to be honest. The problem is that there are some times where the first request comes, where there is no server running to manage that request, and essentially the server has to initialize, the JVM has to start, they have to instantiate your handler before they are able to delegate, and that's typically what we call the startups. So we have done several things to improve that story for Java. For example, for Lambda, we initialize all the singletons eagerly, and all configuration properties eagerly, which is something that works the other way around when you are in Netty. That is lazy. But we do that eagerly because in the initialization phase of Lambda, there is a bit more CPU and resources available. So we do that there. Which times were you seeing for call to startups when using the Java runtime? Let me guess. I guess in the range of 8 to 10 seconds.
Yes, that's right. Yeah, even a little more initially. That's right. Yeah. So then, the question became how do we improve on that? And there is this thing called AWS provisioned concurrency, where AWS says, okay, how about I keep some Lambdas running all the time so that you don't have to worry about cold starts. But then basically that is, in my opinion, kind of defeating the serverless, purpose, because then you have something running all the time. And mind you, having something running all the time is rather expensive. this for a startup. So we started exploring other alternatives, and then we came across GraalVM, native images, which it's quite an amazing tool. We managed to get our API response times for a cold start. So from the time the client makes a request to the time it gets a response back, from more than 10 seconds down to about 1.5 to 2 seconds. While I think the actual Lambda initialization phase is about 700 milliseconds or so. So it got to a point where it was well within our tolerable range. And mind you, this doesn't happen all the time. It only happens when a Lambda is not already warm. So so that managed to solve the problem for us.
That's consistent to what I have seen in the Lambdas that I have. I have a couple of pet projects running on Lambda using Micronaut, and I see and the Lambdas that I have with GraalVM, I see the more or less the same experience as you, around 2 seconds, more or less. So apart from the Java runtime, AWS offers another runtime which is called the custom runtime, I think they call it. And they essentially give you instructions to use kind of the raw infrastructure that they have. And what you do is, if you want to write your own, what the code does is they expose an endpoint, and you have to have like an infinite loop and constantly polling the endpoint for events. And when you receive an event, you can process the event and respond to another endpoint that they give you. And what we did is we actually have that custom runtime implementation done for you. In the custom runtime, you can essentially upload anything that is they can execute. And what we do is we actually generate a GraalVM native image whose starting point is that main class, which does the constant polling and delegates to the other handler that you will typically use when you are using the Java runtime. So from a developer point of view, even if this sounds a bit complicated or I have not expressed it well, you don't have to do anything. So we'll take care of everything for you. And we will generate for you what you have to upload to Lambda. That's typically is a zip file which contains your GraalVM native image. And I think it's a script to essentially execute it. But that's essentially what's happening behind the scenes, is that we go a bit low level and do the constant polling for you. How are you solving are you generating the GraalVM native image in CI? Are you generating locally? How are you working around the slow build time?
So initially everything was happening locally. I think in the first versions of Micronaut, when we started, you were providing some Docker file configuration that we were running. So the native image is built within that Docker container locally, and then we were uploading it ourselves. These days, all of this happens in CI. So all of the Lambda functions that we have, about 15 of them or so, they get built, on CI in parallel, and then they get deployed automatically for the staging and production environments. While dev, usually we don't deploy the native images to avoid the computation time.
That's what I do as well. So I typically actually for Lambda build them in AWS code build, because it has the IAM role to deploy directly to Lambda. But that's great to hear. Both Maven and Gradle Micronaut plugins have Maven goals or Gradle tasks to actually generate that for you. And we have documentation for this. And we have also actually guides as well, which shows you how to do this in the console. And as you were saying, if anyone has any problems, please ask in Gitter. We try to be there to answer any questions.
Just to say around this, initially getting exposed to quite a few concepts, like trying to build a backend, and mind you, we built all the infrastructure for AWS, and we didn't have almost any AWS experience. But we were quite fortunate that Micronaut had a lot of guides that we followed at the beginning, helping us out with both the native images and, the deployments to AWS and Lambda. So we found those to be very helpful.
It is challenging because there are so many things to learn that is overwhelming. You just have to learn about programming, but you have to learn about the whole cloud, different vendors, different services, how to deploy them, etc., etc. How has been your experience with the Micronaut and GraalVM integration? Have you found any block roads?
Not that I remember. Of course, for GraalVM native images, you need some configuration, some I think it's JSON files, isn't it? For anywhere you use reflections, or any libraries that you're using are using reflections, or for dynamic proxies. So we had a few of those cases where we had to understand what was happening there and find the correct reflection or proxy configuration to add into. I should say that since I wrote the article about our experience with AWS Lambda and GraalVM and Micronaut, AWS Mark Sales reached to me and he said in the latest version of the AWS SDK, all of this Graal VM configuration is actually bundled within the SDK, so you don't need anything extra, which I verified on my side. And yeah, I think these days it's much more streamlined as an experience to integrate.
Yeah, it's much more streamlined on the Micronaut side as well than from you when you begin as well. So it's transparent to you mostly, unless you are like, so Micronaut doesn't use any reflection internally. So you typically don't need to like annotate any of our things with type here or anything like that. But if you use a library that uses reflection, you mainly like to provide that reflect config or use the type hint or things like that. But now it's much easier than it used to be. So I'm happy to hear that that's working for you as well. That's really interesting. That's more or less what I have to cover. I don't know. Would you like to cover anything else? Are you using Micronaut aside apart from AWS Lambda, or are you just pure AWS Lambda Micronaut shop right now?
No, pure AWS Lambda.
Nice.
We also use the declarative Micronaut HTTP client that you have. We found that very, very useful. On the mobile development, there is a very similar kind of library called Retrofit. So the transition was quite straightforward.
Yeah, I was hoping that people will find that easy because I have done a bunch of Android development myself, but with Retrofit typically you use as well Mozi, yeah, right, to bind the payload to a response, right? One of the nice things of Micronaut is that you don't need like a library for binding the response POJOs that you get. That's done by the client as well.
Right.
So yeah, but yeah, the Square libraries, Retrofit, HTTP, Mozi, they are really good as well. They're really good.
Yeah, I think with Retrofit you have the option of integrating either a Mozi or JSON or something else.
Or JSON, the Google one.
Yeah, exactly.
Yeah, so we essentially we use the Jackson, or we use actually the new serialization module, but we essentially do that for you, so you don't have to put any other. Have you used any Micronaut are you still doing some Android? Have you used Micronaut in Android at all?
No, I haven't. No.
Yeah, I have to. There are some features of Micronaut that you can use in Android, such as the DI engine and the HTTP client. Actually, the HTTP client you can use in any application. You can use it if you want to use it, even you can use it without a dependency injection. You can just use HTTP client.create, and that will give you like what we call a manual HTTP client. That's cool. So yeah, pretty interesting. Really nice that to hear that your experience is going well. Hopefully some people will be encouraged to try the combination. I am myself quite a fan of AWS Lambda and Micronaut, of course, but the AWS Lambda is kind of my cup of tea as well. So that's nice to hear. Let's jump to the last section of the podcast. So I wanted to thank the sponsors of the Micronaut Foundation, which make this episode possible. Those are objectcomputing.com, which is our ambassador sponsors, Safi.net, which is our bronze sponsor and Visor Games, and as well to all the community sponsors. Thanks all of you. If you are interested in helping the framework, please visit micro.io/foundation. And I would like to thank, of course, Sakis for joining me today. And I wanted to mention a couple of guides as well before we wrap it up. For guides, we have 2 guides which were published, which I wanted to call your attention. One is the using X509 for mutual authentication. We have a guide which shows how to implement mutual authentication using SSL with X509 certificates, which were introduced in Micronaut Security, one of the latest minor versions of Micronaut Security. And we have another version of another guide which shows how to generate, given an open API specification, a Micronaut server, which is one feature that we have with the open API generator. So check them out. Keep an eye on guides.micronaut.io because we are creating more content every week. So that's a good way to learn about Micronaut. And with that in place, Sakis, thanks again for joining me today. And do you want to plug anything before? Actually, plug Caribou, please. What's the URL of Caribou?
Thanks for having us, Sergio. The discussion was great. The URL for Caribou is www.hellocaribou.com. We've built the tool, to help engineering teams out there with their technical debt. We believe that this work of removing technical debt, but also acknowledging all the work that happens from the engineers is very important. And yeah, this is why we built it. So if people want to check it out, or feel free to drop me an email. I would be more than happy to help you out.
Please check it out, everyone. And we listen to each other in 2 weeks. Thanks, everyone, for listening. And yeah, keep using Micronaut. Thank you.